And in another step, methyl free radical again reacts with chlorine. Okay, so it is like you make me free radical. Okay, here chloride free radical converts methane to methyl free radical. So in next step, methyl free radical converts chlorine gas to chloride free radical, and this chloride free radical again reacts with methane to give methyl free radical, and this methyl free radical again reacts with chlorine gas to generate chloride free radical. Thus this is the chain propagation step. Like 2 and 3 step repeat until you will get final product, or until radical quench. Okay, until radical quench. So this is the chain propagation step, and in final step is chain termination step. Chain termination step is like two radical combine together, and they stop the chain. Like two chloride radical combines together to give chlorine gas, two methyl radical forms ethane, and methyl free radical and chloride free radical form CH3Cl, that is chloromethane. Okay, so this is free radical chain reaction. So from this reaction, the question will be like, so free radical chain reaction, what will be the first step? What will be the first step of free radical chain reaction? Under that, they will give option like, which option they will give, I will discuss. So they will give option like free radical will be formed. Okay, free radical will be formed. Another option will be like cations and anions will be formed. Another option will be like nothing will happen, or electrophile will be formed and nucleophile will be formed. So in free radical chain reaction, so free radical will be formed in the first step, that is chain initiation step. So here I have given two type of fission. Okay, bond breakage, like homolytic cleavage. When any compound undergoes homolytic cleavage, then it will generate free radical. Remember this thing. Okay, this is also asked. Okay, after homolytic cleavage what will be formed, or after homolytic fission what will be formed? So after homolytic fission, free radicals forms, and after heterolytic fission, cations and anions will be generated. Okay, so in homolytic fission, free radical, remember this thing. Okay, so they will give option like in homolytic fission what will be formed? So free radicals, and in heterolytic fission what will be formed? So cations and anions. So they will give homolytic fission what will be formed, like they give option free radical, cations, anions. So the answer will be free radicals. So these are the basic thing which we do not focus, or on in the exam. It will be difficult to recall. So these small things you have to remember. Okay, homolytic fission as well as heterolytic fission. So these are the things from free radical chain reaction. And final compound, this chain will be going on and on and on until all hydrogens will be replaced, okay, by chlorine. So you will get here chloromethane, then dichloromethane, then trichloromethane, that is chloroform CHCl3, and finally you will get CCl4, that is carbon tetrachloride. So until all the hydrogens will be replaced, this chain reaction will be going on and on. Okay, so this is about free radical chain reaction. Another important reaction, and another most important reaction for organic chemistry is electrophilic aromatic substitution reaction. Okay, electrophilic aromatic substitution reaction, 3 to 4 questions will be asked from this reaction only. Okay, electrophilic aromatic substitutions reaction. So it is of mainly 5 types: aromatic halogenation, nitration, Friedel-Crafts alkylation, Friedel-Crafts acylation, and sulfonation. We will learn these 5 reaction and which kind of question they will ask in GPAT. Okay, we will learn about that. Free radical chain reaction. So here, sorry, electrophilic aromatic substitution reaction. So first of all, before learning these reaction, all these 5 reaction, we will learn the meaning of these three word. Okay, electrophilic. What is the meaning of electrophile? What is the meaning of aromatic? And what is the meaning of substitution? We will learn this meaning of these three things. Okay, so first is like electrophile. So electrophile is electron loving species, and nucleophile is nucleus loving species. Okay, electrophile, electron loving species. Who loves electron? Which lacks electron, which do not have electron, loves electron. So electrophile is electron loving species. So positively charged ions, okay, positively charged cations, like here I gave example H3O plus, okay, Cu plus 2. These can be electrophile. They can love electron. Why? Because they carry positive charge. They need electrons to become neutral. No compound will like to be present in cationic or anionic form. Every compound will be like to be in neutral form. Okay, so these cations will react with electron and they attract towards electron. That's why these are called as electrophile. Another thing is like atom which have low amount of electron. Okay, here like I gave example BF3. In BF3 boron trifluoride, it is boron trifluoride, 3 fluorine atom is attached. Okay, here fluorine is highest electronegative atom. Okay, fluorine is like highest electronegative atom, and that's why what fluorine will do, fluorine pull electrons towards itself from boron. Okay, from boron fluorine will pull electron from boron, and boron becomes electron deficient. Boron becomes electron deficient. So boron is electron deficient, so it will attract towards electron. Boron becomes electron deficient, so it will attract toward electron, and that's why these become electrophile. Another example which is not cation, but still it is electrophile, that is carbonyl carbon. Carbonyl carbon, in carbonyl carbon C double bond O is there. I gave example of CO2. Okay, just to understand this thing. So C double bond O, here oxygen is highly electronegative atom. Then fluorine, first is fluorine, then oxygen. Oxygen is highly electronegative atom. So what this will do? So oxygen will pull electron towards itself, and carbon becomes electron deficient, and that's why carbon becomes delta positive, and it becomes electrophile. Okay, so this is the meaning of electrophile in electrophilic aromatic substitution reaction. Means in electrophilic aromatic substitution reaction, one word is electrophilic, means electrophile will react. Okay, electrophile will be there in our reaction. We meanwhile we will also understand nucleophile. So nucleophile is nucleus loving species. Nucleus loving species is called as nucleophile. In nucleus there are protons. Okay, so the compound which have more number of electrons, excess of electrons, like anions, Cl minus, Cn minus, these anions have more number of electrons, and that's why they attract towards nucleus. So it is called as nucleophile, nucleus loving species, nucleophile. And another example like ammonia and water, in which nitrogen contains lone pair of electron, excess of electrons. Okay, nitrogen contains lone pair of electrons, means excess of electrons. In water, water oxygen contains excess of electrons, and that's why it becomes nucleophile. So the compound which have less number of electron or electron deficient, it will be electrophile. And the compound or atom which have more number of electron or electron rich, it will become nucleophile. Okay, so are you getting? If you have any doubt, you can unmute yourself and you can ask. Okay. We will do question answer at the last. It's okay. But meanwhile, if in this you have any doubt, you can ask. Okay. I will explain you in other way if you are not getting this thing. Next, in first, so we have started with electrophilic aromatic substitution reaction. We understand the meaning of electrophile. Okay, what is the meaning of electrophile? Next, we will learn what is the meaning of aromatic compound. So, for any compound to call it as aromatic, what is the basic requirement for any compound to call it as aromatic compound? So, there should be certain criteria like there are mainly four structural requirement is there. The compound should be cyclic to call it as aromatic. Okay, so to call compound as aromatic compound, it should be cyclic, it should be planar, it should be completely conjugated. What is the meaning of conjugation? So it should contain alternate double bond or alternate electron, okay, transfer. We will understand in these few slide. And it should contain a particular number of pi electron. That is the this means that it should follow Huckel's rule. Okay, it should follow Huckel's rule. So these are the four main requirement. It should be cyclic, it should be planar, it should be completely conjugated, like alternate double bond should be there. And third one is like it should follow Huckel's rule. Okay, so these four are the criteria to for any compound to call it as aromatic compound. So what is the meaning of Huckel's rule? Okay, cyclic means it should be in cyclic form. Planar means it should be in 2D two-dimensional structure. It should not be like in three-dimensional. It should be completely conjugated. And Huckel's rule. So we will understand Huckel's rule that aromatic compound must contain 4n plus 2 pi electrons. Aromatic compound must contain 4n plus 2 pi electrons, 4n plus 2 pi electron. So like if we take example of benzene, so in structure of benzene, benzene is aromatic compound. So how many pi? So another, first of all, we will discuss about this another three criteria. Benzene, just think about the structure of benzene. It is cyclic, it is planar. Conjugation means alternate double bond. So you can see here, this is double bond, then single bond, double bond, single bond, double bond, single bond. So it has alternate double bond means conjugation. So conjugation, all three criteria is met. Now come to Huckel's rule. It should contain 4n plus 2 pi electron. So if we keep n is equal to 1, here it is shown. If we keep n is equal to 1, then it should contain 6 pi electron. So benzene is having 6 pi electron. Remember this thing, one bond contains two electrons. Okay, so in benzene three pi bonds are there. In benzene structure three pi bonds are there, and that's why six pi electrons are there. So benzene contains 6 pi electrons, so it also fulfills Huckel's rule, and that's how benzene becomes aromatic compound. Okay, if any compound follows these four criteria, then and then only it can be called as aromatic compound. This is about aromaticity. But in GPAT exam, they ask about anti-aromatic compound. Anyone know about anti-aromatic compound? So anti-aromatic compound is like it should follow all these three criteria. First three criteria compound should follow. It should be cyclic, it should be planar, it should be completely conjugated. Okay, for compound to be anti-aromatic, these three criteria should be for. Okay, cyclic, planar, completely conjugated. Now The fourth one, Huckel's rule. Huckel's rule is 4n plus 2 pi electron, then it will be aromatic. If compound contains 4n pi electron, okay, only 4n pi electron. Just I have given example here, okay. You can see, I will move this here. You can see example of 1,3 cyclobutadiene. 1,3 cyclobutadiene. I have given example of 1,3 cyclobutadiene is, so it is cyclic, it is planar, it have conjugation, alternate double bond, single bond, double bond, single bond, alternate double bond. Conjugation is also there. But pi electrons, if we count pi electrons, so it contains 4 pi electrons, and that's why it becomes anti-aromatic. Okay, are you getting? If you have any doubt, you can ask. Okay, so what is the meaning of
सर
anti-aromatic? Yeah,
सर साइक्लिक एंटी एरोमेटिक का साइक्लिक प्लेनर एंड कंप्लीटली कंजुगेटेड होना चाहिए, उसमें हक्कल रूल फॉलो नहीं करना चाहिए कंपाउंड, ऐसा है?
या हकल रूल फॉलो नहीं करेगा, और उसमें क्या होगा, 4n पाई इलेक्ट्रॉन हो गए। हकल रूल में क्या है कि 4n प्लस 2 पाई इलेक्ट्रॉन्स है। 4n प्लस 2 मीन्स, जस्ट सेकंड, yeah, 4n plus 2 means it should contain either 2 pi electron, 6 pi electron, 10 pi electron, 14 pi electron, 18 pi electron. Okay, if compound have this much pi electrons, then it will be aromatic. But according to anti-aromaticity, compound have 4n pi electron. 4n means 4, 8, 12 in multiplication of 4. Okay, if
यस.
compound have 4n pi electron, then it will become anti-aromatic compound. Okay, so I have given a few examples here. Just look at this. First, benzene. Benzene have 6 pi electron. It is cyclic, planar, conjugated, 6 pi electrons, so it becomes aromatic. Another example is naphthalene. Naphthalene having 10 pi electron, 5 pi bonds, and it has 10 pi electrons, so it is also aromatic compound. If we talk about anthracene, three-member structure, so three-member structure, so it is also aromatic compound. Now, if we talk about this compound, can you see cursor on my screen? Okay.
यस.
So it is 1357 cyclooctatrine. 1357 cyclooctatrine. So can you tell me, is it aromatic or not? Can anyone tell about that ki this is aromatic or not? It is
नॉट एरोमेटिक.
it is cyclic, it is
एंटी
cyclic, it is
एरोमेटिक.
planar. Yeah, very good. So it is cyclic, planar, conjugation is also there, and if we count pi electron, then it has 8 pi electrons. Okay, it has 8 pi electron, and that's why this compound becomes anti-aromatic. Okay, so why anti-aromatic? Because it contains 8 pi electron. It follows other three requirement, but the fourth requirement, that it should follow Huckel's rule, that it is not following Huckel's rule. It has 4n pi electron, and and that's why it becomes anti-aromatic. This compound, like it has 4 pi electron. How this compound becomes anti-aromatic? How? So 2 pi electrons are here, and another 2 electrons. Okay, this is anion. Okay, anion is here. So this compound becomes anti-aromatic. Okay, here non-aromatic. Why? Because conjugation is not there. If compound does not contain conjugation, then it will become non-aromatic. Okay, it will be cyclic, planar, everything is okay, but conjugation is must requirement for compound to call aromatic or anti-aromatic. Just like this compound, if we take example of this compound having positive charge on this atom, okay, then it will become anti-aromatic. because it contains 4 pi electron, and if it have negative charge on this atom. Okay, 5-membered ring, cyclopentadiene. I am talking about cyclopentadiene. Just you can see my cursor. Okay, so uh, negative charge is there, then the count of pi electron will become 6. Okay, 2 and 2, 4 electron in bond, and another 2 electrons in this negative charge. Okay, anion. So it will become aromatic. Okay, just so here these 2 electron, and that's why it become aromatic. 6 pi electrons are there. Here positive charge is there, and that's why if without positive or negative charge, okay, if this cyclopenta 1,3-cyclopentadiene 1,3-cyclopentadiene does not contain positive or negative charge, then it will be aromatic or anti-aromatic. Can anyone give an answer? Anyone can give answer? If 1,3-cyclopentadiene, like this compound, okay, this compound do not contain any charge on this atom, okay, then it will be aromatic or anti-aromatic.
एंटी एरोमेटिक, क्योंकि इलेक्ट्रॉन्स का बॉन्ड्स बनने में प्रॉब्लम होगा ना।
So it will be non-aromatic.
हाँ।
It will be non-aromatic. Why? Because here it is aromatic and anti-aromatic. Why? Because of this negative charge. There is uh, p orbital is there. Okay, p orbital is there on this carbon. Okay, p orbital is there on this carbon. But in case of compound having no charge, then it will be like CH2 hanging outside the plane. So two things are there. The compound will become non-planar, and it will have it will not have conjugation. Okay, so no conjugation and non-planar. So two requirements it will not follow, and that's why it will become non-aromatic compound. So I have given another few example like furan, indole, pyridine. All these are aromatic compound. These example tropyl tropylium ion. Okay, they ask many time. So tropylium ion is aromatic or anti-aromatic. They will give some question like that. So remember this thing. Tropylium ion, the 7-membered cycloheptatrine, 7-membered cycloheptatrine with cation on the ring. It is tropylium ion, and it becomes aromatic. Okay. If this compound tropylium ion contains negative charge here, okay, if it is negative charge, then what will be the nature of compound? Aromatic or anti-aromatic or non-aromatic? Anyone? Tropylium
नो
ion,
एरोमेटिक।
negative charge, it will be anti-aromatic. So negative charge, if the compound will have negative charge, then it will become anti-aromatic. Why? Because two, three double bonds are there, three double bonds are there. So it will be 6 pi electron, and a negative charge 2 electron. So it will become anti-aromatic. So the compound will be anti-aromatic in nature. So this is all about aromaticity. We have started with electrophilic aromatic substitution reaction. So the first word electrophile, we understand what is the meaning of electrophile. Positively charged or electron deficient atom is called as electrophile. Negatively charged or electron rich atom calls as nucleophile. Okay. Then aromaticity. So for any compound to be aromatic, it should follow four criteria. It should be cyclic, planar, okay, cyclic, planar, conjugated, double bond, okay, conjugated system. It should contain conjugated system. And fourth one is it should follow Huckel's rule. If compound follow all these four criteria, then the compound will become aromatic. And if it deviates from any two criteria, if compound deviate from any two or more criteria, then it will be non-aromatic. If compound have four and pi electron, then it will become anti-aromatic. Okay. So if you they in GPAT they ask by giving structure of any compound or name of any compound. Okay, like what is the nature of tropylium ion? Aromatic, anti-aromatic, non-aromatic, aliphatic. So the answer will be it will be aromatic. Okay, tropylium ion will be aromatic. Naphthalene will be aromatic. Now if they give option like benzene is aromatic. Why? Benzene is aromatic. Why? So if they give an option like it is cyclic, it is planar, it contains it follows Huckel's rule, and all of the above. So the option will be like all of the above. Okay. So they just twist the question and they will ask like that. Okay. So you have to
नॉन एरोमेटिक कैसे पहचाने एक बार बताओ ना फिर से.
for non-aromatic, four requirements are there for any compound to be aromatic. Okay, four requirements like cyclic, planar, completely conjugated, and it should conjugated and it should follow alternate double bond. Okay, so non-aromatic compound deviate from two requirements. Okay, like it is cyclic. Like I have given example here. This compound it is cyclic. It is planar. Okay, but it is not planar. Why? Because two CH2 are out of the plane. Here two CH2 atoms are there. Okay, one CH2 here and another CH2 here. Two CH2 are out of the plane and conjugation is also not there in the compound. So it will become non-aromatic. Okay, like if you take example of compound like uh, we take a, 1,3 cyclopentadiene, 1,3 cyclopentadiene, 1,3 cyclopentadiene. Without any charge, this compound will become non-aromatic. Why? It is cyclic. It contains four n pi electron. Four n pi electron is there, but it does not contain conjugation. Means more than two requirements they will deviate from that. Okay, conjugation mostly in non-aromatic compound there will be no conjugation. Conjugation will be not there in non-aromatic compound. If conjugation is there, if conjugation is there, then it will be either aromatic or anti-aromatic. If it lost conjugation, then the compound will become non-aromatic. Okay, are you getting?
Yes, sir.
So till now, anyone have any doubt? If you have any doubt, you can ask. Okay. So next, till this slide, we talk about two words, electrophilic and aromatic. And third word is substitution reaction. So before going to substitution reaction, we will talk something about addition reaction. Okay. So addition reaction, we are for a few minutes, we will go out of this topic. Addition reaction, what is the meaning of addition reaction? So I have given example like if compound have double bonded carbon, example like ethene. So ethene is there, ethene reacts with bromine and it will form dibromoethane. Okay, just like hydration, if ethene reacts with water, it will form on one carbon hydrogen will be added and on another carbon OH will be added. Okay, if we take example of hydrogenation, so on one carbon hydrogen and on another carbon hydrogen. So it will become ethane and polymerization reaction. Except this, you have also learned Markovnikov addition reaction, anti-Markovnikov addition reaction, and all other reactions. Okay, like if HCl is added, so chloroethane will be produced. So this is about addition reaction. Here substitution is not possible. These reactions are about addition reaction. Addition reaction. Okay. So the general scenario is like alkene. These are alkenes. Okay. So alkene undergoes addition reaction. This is general scenario. Alkene undergoes addition reaction. So if we look at the structure of benzene, so structure of benzene, it is like 135 cyclohexatriene. Okay, 135 cyclohexatriene. It contains three double bond. It is from alkene series because it contains double bond. Alkene, cycloalkene. Okay, cycloalkene. If one double bond is there in cyclohexane, then cyclohexene, two double bond, like this in this example, it will become it will become 1,3-cyclohexadiene, and benzene is 1,3,5-cyclohexatriene. Okay, so benzene, according to this scenario, benzene should undergo addition reaction. Benzene should undergo addition reaction. So I have given, so if benzene reacts, benzene is cyclohexatriene. Okay, and it should undergo addition reaction, but in general way. When benzene is reacted, just take example of bromine. Okay, benzene plus bromine, here dibromoethane is formed. So according to addition reaction, one double bond will be removed, and one double bond will be removed, and Br will be added. Two bromine will be added on this ring, and it will form dibromo compound. Okay, dibromo compound will be formed in addition reaction, but it is not in the case of benzene. Though benzene is alkene like molecule, it undergoes substitution reaction. What is the meaning of substitution reaction? So in substitution reaction, one atom substituted by another atom. Substitution reaction is like one atom is substituted by another atom. So benzene ideally should undergoes addition reaction because it is from cycloalkene series, but it does not undergo addition. Instead, it undergoes substitution. So what is the reason? Question from GPAT. Okay. What is the reason why benzene undergoes substitution reaction? They will give long big sentence, four option. Okay, what is the reason? Anyone can answer? The only reason benzene undergoes substitution reaction is resonance. Okay, in benzene alternate double bonds are there. In benzene alternate double bonds are there. These alternate double bonds contributes to its resonating structure. Okay, you know about resonance. I or Yeah, you can just see the structure of benzene. We draw a circle inside the ring. Okay, so it is a resonating structure of benzene. So due to alternate double bond, pi electrons not stay on single atom. Okay, due to alternate double bond, pi electrons do not stable on single electron, rather it circulate in the ring. Okay, circulate in the ring, and that's why the reason benzene does not undergo addition reaction, but it undergoes substitution reaction, resonance, because of resonance. Okay, remember this thing. They will give big line sentence in option. Okay, four option, but you have to identify the correct with your knowledge. Okay, the option will should be like they can change. Okay, change the language, but you have to identify where resonance. Okay, where is the where they try to say resonance, you have to choose the that option, and you can give answer. Okay, so this is all about electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. Okay, electrophile means positively charged or electron deficient species. Aromatic compound means it should be cyclic, planar, conjugated, and follow Huckel's rule for n plus 2 pi electron. And substitution reaction, why substitution reaction? Because of resonance. Okay, so electrophilic aromatic substitution reaction, nitration, sulfonation, halogenation, Friedel alkylation, and Friedel Crafts acylation are there. Okay, so mechanism of these reactions, sometimes they ask these steps. Mechanism of electrophilic aromatic substitution reaction. So it is like three-step reaction. In first step, generation of an electrophile. Second step, electrophile reacts with aromatic ring to generate uranium ion. Remember this word. Okay, and this step is rate determining step, slowest step in the reaction, second step. Okay, generation of, so electro first step is generation of electrophile. First of all, electrophile will be generated, then electrophile reacts with aromatic ring, means benzene ring, and it will form uranium ion. Remember this word. Okay, uh, before this, the another word is troponium ion. Okay, this is uranium ion. And third step is loss of proton to regenerate aromatic ring. Loss of proton to regenerate aromatic ring. So if we take an example of simple nitration reaction, so HNO3, H2SO4, HNO3 and H2SO4, you will get a nitrobenzene from benzene. So what is the reaction mechanism? So first step is generation of electrophile. So I have shown first step here. HNO3, HNO3, the structure of HNO3 is like this. Okay, NO2OH, NO2OH. So H2SO4, what is the role of H2SO4? H2SO4 protonate this oxygen, okay, and it will generate NO2 plus. Now you can see NO2 plus. NO2 plus charge is there. It is cation, it is electron deficient, so it is electrophile. So that is the first step of our reaction, generation of electrophile. So in this reaction, which electrophile is generated? NO2 plus. Okay, NO2 plus is generated in this reaction. This is the electrophile, first step. Now second step, electrophile reacts with aromatic ring. Okay, electrophile reacts with aromatic ring to generate uranium ion. So this is positive. This positively charged ion is called as uranium ion. Okay, this is uranium ion. NO2 plus. This electrophile reacts with aromatic ring to generate uranium ion. And last step is loss of proton. So this proton is abstracted, and regeneration of aromatic ring. Thus you will get nitrobenzene. So three steps are there. First step is generation of electrophile. In nitration, NO2 plus is generated. Remember this thing, okay? Which electrophile is generated in which reaction? In nitration, NO2 plus is generated. Okay. Mechanism, second step, NO2 plus electrophile reacts with aromatic ring to generate uranium ion. Uranium ion. Okay. And last step is loss of proton to regenerate aromatic ring. Thus, compound will be formed. So in nitration, electrophile will be NO2 plus. Next is sulfonation. Sulfonation. So for sulfonation, 2 moles of H2SO4, 2 moles of H2SO4 is used, and it will form benzene sulfonic acid. Here, first step, generation of electrophile. So 2 mole of H2SO4 reacts together to generate SO3H plus. SO3H plus. This is the electrophile. This electrophile reacts with aromatic ring to generate uranium ion. This step is slow step. It is rate determining step. And finally, loss of proton. This proton will be kicked off to regenerate aromatic ring, that is benzene sulfonic acid. Okay. Sometimes they will give which reagent will be used for to carry out sulfonation reaction. Which reagent? GPAT question is it is okay. Which reagent is used to carry out sulfonation? Which reagent is used to carry out sulfonation? The option will be HNO3, HCl, oleum, or acetic acid. Okay. Option. Question is sulfonation. Which reagent is used for sulfonation? Option will be like HNO3, HCl, oleum, oleum, and another option is acetic acid. So what will be the answer? Can anyone say? Can anyone answer this question? Which reagent? So I will type in text box. Oleum, very good. Okay, Yoga Chaitanya. Oleum. So oleum, what is the meaning of oleum? So when you keep 2 moles of concentrated H2SO4 together, so it will form this structure. Okay, 2 moles of concentrated H2SO4 form this structure, and it is called as oleum. Okay, oleum, and this oleum is nothing but H2SO4. 2 moles of H2SO4 combines together to form oleum. If you add water in oleum, it gives 2 mole of H2SO4. If you add water in oleum, it forms 2 mole of H2SO4. So the answer is oleum. Remember it. Okay. Oleum is used for sulfonation reaction. Then another reaction is halogenation reaction. Halogenation reaction. So you all know about halogenation. Br2 FeBr3 is used. Br2 FeBr3 bromination, bromobenzene will be formed. So now if you take Cl2 FeCl3, then you will get chlorobenzene. First step is generation of electrophile. Generation of electrophile. Why FeBr3 is used in this reaction? They ask many times. Okay, why FeBr3 is used in this reaction? Now here, first in first few slides we learn about homolytic and heterolytic cleavage. Okay, homolytic and heterolytic cleavage. If compound undergoes homolytic cleavage, it will form free radical, and if compound undergoes heterolytic cleavage, it will form cations and anions. For this reaction, we need cations and anions. Okay, so it is very difficult to form Br plus and Br minus from Br2. It is very difficult to form Br plus and Br minus from Br2. So what is the role of FeBr3? It increase polarity of this Br-Br bond. Okay, here there is no polarity. They are very stable molecule. Br2, Br and Br. No positive, no negative charge. No one will pull electron. Okay, no one will be electron deficient. No one will be electron rich. Both Br are satisfied with their life. Okay, both Br are satisfied with their life. But FeBr3 came in their life, and what happened? One become Br positive, okay, and another will become Br negative. So these is the first step of the reaction, generation of electrophile, generation of electrophile by activation of Lewis acid. FeBr3 is called as Lewis acid. Okay, so Lewis acid is used to increase the polarity of Br-Br or Cl-Cl single bond. Okay, increase polarity of this bond, increase polarity of this bond by FeBr3 Lewis acid increase the polarity of bond, and that's why it can react in second step. Okay, this electrophile react with benzene ring and it will generate uranium ion. Uranium ion is formed, and in last step, loss of proton to regenerate aromatic ring, and here FeBr3 also regenerated. This regenerated FeBr3 is used for another reaction. Okay, so FeBr3 is used as catalyst. Okay, so this is the main question asked from this halogenation reaction. What is the role of Lewis acid in halogenation, electrophilic aromatic substitution, halogenation? Okay, so role of this Lewis acid is to increase polarity of bond. It increase polarity of bond. Br bond polarity will be increased. Now we talk about chlorination. You can get chlorobenzene. You can get bromobenzene. Okay, but fluorobenzene and iodobenzene synthesis is not possible by halogenation reaction. Fluorobenzene and iodobenzene is not possible to synthesize by halogenation reaction like F2FeF3 or I2FeI3. This reaction is not possible. Why? Because why? Because if we talk about iodine, then iodine is too much unreactive molecule. Okay, iodine is too much unreactive molecule. It has nothing to do with these all. So iodine does not react at all in electrophilic aromatic substitution reaction, and because of its unreactivity, iodination is not possible. Iodination is not possible. While if we talk about fluorine, okay, fluorobenzene, synthesis of fluorobenzene. So fluorine is too much reactive compound. Fluorine is too much reactive, very reactive. It is totally unstable molecule, fluorine F minus. So it is also not possible F minus F plus generation. So fluorine is too much reactive, while iodine is too much unreactive, not reactive at all. Iodine is not reactive, fluorine is very reactive. That's why fluorination and iodination is not possible in electrophilic aromatic halogenation reaction. Okay, remember this thing. So from halogenation, what you have to remember, iodination is not possible because iodine is too much unreactive. Fluorination is not possible because fluorine is too much reactive. These two things, and another thing is use of Lewis acid. Use of Lewis acid in halogenation. So what is the use of Lewis acid? So Lewis acid increase the polarity of Br single bond. Lewis acid increase the polarity of Br single bond. Okay, and it forms electrophile. Okay, to generate electrophile. FeBr3 is called as Lewis acid. Lewis acid. Okay, so this is about halogenation. Next reaction is Friedel-Crafts alkylation and acylation. Okay, Friedel-Crafts alkylation and acylation. So as we know, for alkylation RCl and for acylation RCOCl is used. Here also Lewis acid like AlCl3 is used. What is the role of AlCl3? Same as FeBr3. Here RCl bond is stable bond. Okay, RCl bond is stable bond. So AlCl3 came into picture. It increased the polarity of this bond. It increased polarity of this bond, generate this Ca3 plus cation, and it will be converted into AlCl4 minus. Okay, for Friedel-Crafts alkylation, you will get alkyl benzene. Friedel-Crafts acylation, you will get acyl benzene. Simple question. Okay, if this compound in Friedel-Crafts alkylation, chloromethane, chloromethane reacts with benzene in presence of AlCl3, what will form? Chlorobenzene plus, sorry, chloromethane plus benzene, chloromethane plus benzene. it will give you toluene. Okay, simple. It will give you toluene. If CH3COCl, CH3COCl, it is called as acetyl chloride. Okay, CH3COCl. CH3COCl reacts with benzene. Then what will be formed? No, not anisole. Here it is very tricky. Okay, so CH3COCl will form acetophenone. These questions, this question was asked 2 to 3 times. Simple question. You will know the structure of compound, but name of compound is very difficult. Okay, so CH3CO and phenyl ring, it is called as acetophenone. Remember this. Okay, acetophenone will be formed. Acetophenone will be the name of this compound, CH3CO and benzene ring. CH3CO and benzene ring, acetophenone. Okay, so this is about electrophilic aromatic substitution reaction. Okay, next we will take a 5 minutes break. Okay, because if we continue this lecture, we will take just 5 minutes break and we will come back. Okay, I'll come back within 5 minutes. Just revise whatever I have taught. Okay, electrophile means what? Aromaticity means what? And electrophilic aromatic substitution reaction, 5 reaction. What is the important thing in each and every reaction, like nitration, sulfonation, acylation, alkylation, and halogenation? Okay, I will take 5 minute break and I will come back within 5 minutes. Till now, anyone have any doubt? Am I audible? Okay. So if you have any doubt, you can ask. We will start next. After this Friedel-Crafts alkylation, electrophilic aromatic substitution reaction. Okay, so if you carry out nitration of benzene, you will get nitrobenzene, you all know. If you carry out nitration of toluene, okay, if we carry out nitration of toluene, then we will get orthonitrotoluene and paranitrotoluene. If we carry out nitration of nitrobenzene, nitration of nitrobenzene, okay, HNO3, H2SO4, we will get three products, but the major product will be metadinitrobenzene. Okay, nitration reaction. We will focus on nitration reaction because reagents are very easy. HNO3, H2SO4. Nitration of nitrobenzene, nitration of benzene gives nitrobenzene. Nitration of toluene gives orthonitrotoluene and paranitrotoluene. And nitration of nitrobenzene gives major product metadinitrobenzene. So in one case, you are getting ortho and para mixture of ortho and para product 50-50 ratio. Okay, 50 or 50 percentage ortho, 50 percentage meta. But in case of nitrobenzene, you are getting major product metadinitrobenzene. What is the reason behind this? Okay, so here some groups are electron donating groups while some groups are electron withdrawing group. Okay, some groups are electron donating group and some groups are electron withdrawing group. So here I have seen resonating structure of these groups. So what is the role of electron donating group? Electron donating group donates electron to phenyl ring while electron withdrawing group withdraw electrons from phenyl ring. Okay, electron donating group donate electrons, electron withdrawing group withdraw electrons. Okay, electron donating groups are donating electron, and that's why the ring is easily available for electrophile. We are learning about electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. So electrophile will come towards ring. Okay. So if you have two ring with like one is benzene ring and another one is electron benzene ring with electron donating group. Okay. So electron donating group donate electron to benzene. So benzene is already having electron, but electron donating group donates more electron. So electrophile will first go to compound which contain electron donating group. Okay, are you getting? And what is the role of electron withdrawing group? Electron withdrawing group withdraws the electron from the ring. Okay, withdraw electron from ring. So electrophile will come, but benzene ring electron withdrawing group already withdraws electron, so it will be deactivating group. Okay, electron donating group will become activating group. Why? It promotes electrophilic aromatic substitution reaction, and electron withdrawing group becomes deactivating group. Electron withdrawing become deactivating groups. Why? Because it deactivate ring for electrophilic aromatic substitution reaction. Electron withdrawing group withdraw. It pulls electron towards itself while electron donating group donate electrons. Okay, are you getting why it is activating? Because electrophile is positively charged ion. Positively charged ion electrophile electron loving species. Benzene have electron, but if you give more electron, then the attraction will be more. Thus, it become activating group, electron donating group. Electron withdrawing group, it withdraws electron. Electrophile will come, but not like benzene. Okay, so it is deactivating group. Now, remember this thing: electron donating group, it is activating group, and it is orthopara directing group. Okay, electron donating group, it is activating group and it is orthopara directing group. Electron withdrawing group is deactivating group and it is meta directing group. Okay, so the group which are under classification of electron donating group, they are activating groups and they are orthopara directing groups, and the groups which are electron withdrawing group, they will become deactivating group and meta directing group. Remember this thing. Okay, so you have to just identify which one is electron donating group and which one is electron withdrawing group. Okay, why electron donating group is orthopara directing? So we will discuss it. So electron donating group donate electrons and it increase electron density on ortho and para position. Okay, it increases electron density on ortho and para position. So electrophile will come, okay, and it will attach with ortho and para position. Why? Electron donating group donates electron to ortho and para position, while electron withdrawing group withdraw electron from ortho and para position. Electron withdrawing group withdraw electrons from ortho and para position. So electrophile have also only one option. Electrophile will have only one option. Electron withdrawing group we already withdraws electron from ortho and para position. So only meta position it can fit itself. Okay. That's why electron donating group gives ortho para attack because it is orthopara directing group because it increase electron density on ortho and para position, while electron withdrawing group withdraws electron from ortho and para position, and that's why you will get meta product. Okay, are you getting any doubt? You can ask. So electron donating group orthopara directing group, electron withdrawing group meta directing group. Two questions will be there from these electron donating and electron withdrawing groups. Okay, remember this thing: electron donating group activating. Why? Because it donate electron, so electrophile reacts fast, and electron withdrawing group withdraw electron, so electrophile reacts slowly, so it will be deactivating group. Electron donating group orthopara, electron withdrawing group meta directing group. Now next is how to identify electron donating and electron withdrawing group. But before before that, I will just mm, include something like electronegativity order. Electronegativity. Okay, so fluorine is the highest electronegative, then oxygen, then nitrogen, then carbon is equal to sulfur, and the lowest electronegative is hydrogen. Okay, so this is the electronegativity order. Fluorine is the highest electronegative, then oxygen, then nitrogen, then carbon, and last one is hydrogen. So how to identify electron donating and electron withdrawing group? Just remember these two examples like CH3. CH3 is electron donating group and NO2 is electron withdrawing group. In CH3, directly attached atom is carbon. Directly attached atom is carbon and neighboring atom is hydrogen. So if electronegativity of directly attached atom is higher, then it will become electron donating group, and if electronegativity of directly attached atom is low, like here nitrogen's electronegativity is less and oxygen's electronegativity is more. You can see from this equation. Okay, fluorine, oxygen, nitrogen. In NO2, nitrogen's electronegativity, nitrogen is directly attached. Nitrogen's electronegativity is low and oxygen's electronegativity is higher. That's why it becomes electron withdrawing group. So you just have to remember these five atoms: fluorine, oxygen, nitrogen, carbon, sulfur, hydrogen. Okay. Fluorine have highest electronegativity, then oxygen, then nitrogen, then carbon, and last one is hydrogen. So according to that, these are the example of electron donating group. You can see oxygen, then Nr2. Nr2 means two carbons are there. So nitrogen's electronegativity is higher than carbon. That's why it becomes electron donating group. NH2 again, nitrogen is high electron negativity, and that's why it becomes electron donating. OH, O, R means oxygen, neighboring atom is carbon. NHC, okay, nitrogen, two atoms attached with nitrogen, hydrogen and carbon. So it is also electron donating group. So the basic concept or basic funda is like that. If directly attached atom have high electronegativity, then it becomes electron donating group. And if directly attached atom have low electronegativity, like here you can see CHO aldehyde, carbon and oxygen. Oxygen neighboring atom have high electronegativity, so electron withdrawing group. Okay, another example COOH, COOR, COCl. Another example here CF3. Okay, carbon and fluorine. Fluorine have high electronegativity. That's why it becomes electron withdrawing group. Here nitrogen, CN in CN. Nitrogen have high electronegativity, electron donating group. SO3H, okay, sulfur and three oxygens attached to it. So it is strongly deactivating group, strongly deactivating group, okay. In some example, here you can see NH3, N plus R3 and NO2, okay. These, if positive charge come in the structure, then it becomes electron withdrawing group, because here nitrogen have no electron to donate to the ring. That's why it becomes electron withdrawing group. So just remember this thing. You have to remember this order. If directly attached atom have high electronegativity, then it will be electron donating group. If directly attached atom have low electronegativity or positive charge, then it will become electron withdrawing group. Okay, are you getting any doubt? So here we can see, like benzene is reference point. Benzene is reference point. So activating group, that is electron donating group. Here example methyl. Methyl is weakly activating group, while OH, phenol, in phenol OH is strongly activating group, because carbon have low electronegativity and oxygen have high electronegativity. So oxygen can donate electrons more. Oxygen have lone pair of electron and it can donate electron more as compared to methyl. That's why it becomes strongly activating groups. In same way, if we look at this side, fluorine halogens are weakly deactivating group, while NO2 is strongly deactivating group. Okay, the exception is like that. In electron donating group you will get ortho para attack. Okay, ortho chloroaniline. If we carry out halogenation of aniline, then you will get ortho chloroaniline and para chloroaniline. But halogens are exception. Okay, halogens are exception. Why? So it is like halogens are electron withdrawing group, but still they give orthopara attack. Okay, halogens are electron withdrawing group. Till now we have learned that electron withdrawing group give meta product. Electron withdrawing, if benzene ring containing electron withdrawing group, then it will give meta product. But in this case, halogens are electron withdrawing group, but still they give orthopara product. Why? So the electron withdrawing effect. Electron withdrawing effect is due to its inductive effect. Okay, halogens are inductively very strong. So because of inductive effect, it withdraws electron from aromatic ring. Because of inductive effect, it withdraws electron from aromatic ring. But because of resonating effect, because of resonating effect, it gives orthopara product. So this question can be asked. Okay, and three times it has already been asked. Which question? Halogens are electron withdrawing group, but still they are orthopara directing. What is the reason? They will give option. Electron withdrawing is because of inductive effect. Electron withdrawing is because of inductive effect. Electron withdrawing is because of inductive effect. And orthopara direction is because of resonating effect. Orthopara direction is because of resonating effect. Electron withdrawing because of inductive effect, and orthopara direction is because of resonating effect. Okay, so remember this thing. Halogens are exception. Okay, so next I have given few examples like if you have two methyl group, methyl is orthopara directing group, but here para position of both are occupied, so you will get only one product, that is ortho. Okay, to this CH3. If you have one methyl and one nitro substituent on the ring, so methyl is orthopara directing and nitro is meta directing group. So you can see para position is filled. So ortho product, you ortho to methyl, you will get this product. And nitro group is meta directing, so ortho meta. So this is about bromination. Okay, and here is the question: if you have two group like OH and CH3, then which product you will get? Because both are electron donating group. OH is also electron donating group and CH3 is also electron donating group. Both are activator, both are activating group. So both are orthopara directing group. Both para position are fulfilled. Okay. Para attack is not possible. So ortho attack is possible. So there are two chances. So incoming group like here bromine can go ortho to either to OH as well as ortho to methyl. But as OH is very strong activating group because of its electron donating nature, so OH will be OH will become directing group and the product will be uh, ortho to OH group. Okay, so you will get this product. While in this case, okay, this trimethyl, okay, trimethyl group, okay, CH3 and CCH3 thrice, both are equally activating group. In last example, both are equally activating group, but this incoming group will go ortho to CH3. What is the reason? So here there is no effect of electron donating nature. Here steric factor will play a role, crucial role. Like here it is a very bulky group CCH3 thrice. If we draw the structure, like it is very bulky and it will be difficult for ortho attack to this CCH3, and that's why you will get a product ortho to methyl group, okay, and not to CCH3 group. So this is all from electrophilic aromatic substitution reaction. Okay. Next, do you have any doubt till now? Next, with few slides, we'll complete. Okay. So if you are getting bored, yeah, yeah. If you have any doubt, you can ask. Next is basicity of amines. Okay. So basicity of amines, like they ask sometimes about the basicity of amines and acidity of aromatic carboxylic acid. Okay. So if we talk about aromatic amines and aliphatic amines, so aliphatic amines are more basic as compared to aromatic amines. So what is the role of basicity? So basicity means according to Arrhenius acid-base theory. According to Arrhenius acid-base theory, base is the compound which can accept proton. Base is the compound which can accept proton. Okay, so here amines amines become base. Why? Because it accept proton. Okay, it accept proton, and that's why it can be called as base. But the strength of amine here, nitrogen have lone pair, and that's why it can accept proton and it becomes basic in nature. Here also nitrogen have lone pair and it can accept proton and it becomes basic. Okay, but aliphatic is more strong and aromatic is less strong. Why? Because in aromatic compound, lone pair of nitrogen is donated to aromatic ring. As we have discussed, NH2. NH2 is electron donating group. NH2 is electron donating group. NH2 is electron donating group. So it donates its electron towards aromatic ring. So it is less available for incoming H plus ion. It is less available for incoming H plus ion. So as NH2 in aniline is electron donating group and it donates electron, so it H plus is less readily attached to aniline, and here no donation, nitrogen have its whole lone pair of electron, and it can accept H plus strongly as compared to aniline. Thus aliphatic amines are more strong base as compared to aromatic amines. Okay, why? Because in aromatic amine lone pair is donated to aromatic ring, and that's why aromatic amines become less basic. Okay, this is one example. Another example is like, if we take comparison of aniline with aniline having electron donating group at para position and aniline having electron withdrawing group at para position. Okay, so here we can say aniline is basic in nature. Aliphatic and aromatic is completed. Here we conclude that aliphatic amines are more basic. Now we are talking about aromatic amine. Okay, now we are talking about aromatic amine. So we take example of aniline, para-nitroaniline, and para-methylaniline. Okay, para-methylaniline. Just to para-methylaniline have some other name, but to understand, we just tell it as para-methylaniline. Okay, so aniline, para-nitroaniline, and para-methylaniline, which will be more stronger base? Okay, which will be more strong base? Aniline, para-nitroaniline, or para-methylaniline? Okay, so para-methylaniline, correct. Why? Because here nitrogen donates its lone pairs to aromatic ring. But if another electron donating group is attached, methyl is electron donating group. If another electron donating group is attached at para position, then it will donate electron to aromatic ring, or nitrogen burden will be less. Nitrogen's burden will be less. So electron donating group increases basicity, while electron withdrawing group, what will be the role of electron withdrawing group? Nitrogen needs electron to prove itself as base. Nitrogen needs electron to prove itself as base, but electron withdrawing group withdraws electron from ring, and hence it withdraws electron from NH2. Okay, so it becomes less basic. It destabilize this cation, and it decrease the basicity. Okay, so remember this: electron donating group increases basicity by stabilizing cation. Electron withdrawing group decreases basicity by destabilizing cation. Which cation? So this NH3 plus cation. Okay, NH3 plus cation. So this NH3 plus, as we have started with that line, anyone wants to be in neutral form. Okay, any compound wants to be present in neutral form. No compound likes to be present in cationic or anionic form. Here nitrogen is in cationic form. Okay, cationic form. It wants to be neutral. So here if electron donating group came in picture, it donates electron. So nitrogen will get relief. Ah, someone is donating electron to me, and it becomes stabilized. Okay, it becomes stabilized. But in electron withdrawing group, this is like a cation, and electron withdrawing group withdraws electron. Okay, this is like poor, and electron withdrawing group make it much poor. So it becomes destabilized, and thus it decreases the basicity of aniline. Okay, so this is about basicity of aniline. In same way, if we talk about acidity of carboxylic acid, so carboxylic acid is acid. Why? Because it donates H plus ion. It donates H plus ion. So RCOOH plus water, you will get RCOO minus. Here COO, this compound is in the form of COO minus. So the group, if we talk about electron donating and electron withdrawing group, the group which stabilize this anion will increase the acidity of carboxylic acid, and the group which destabilize this anion decreases the acidity of carboxylic acid. So can you tell me, electron donating and electron withdrawing group, two groups are there. Okay, electron donating and electron withdrawing groups are there. Which group will increase the stability of this anion? Can anyone tell? You have two group, electron donating group and electron withdrawing group. Which group? On benzene ring. Okay, you have two groups on benzene ring. Like just take example. Okay, para-nitrobenzoic acid and para-methyl benzoic acid. Para-nitrobenzoic acid and para-methyl benzoic acid. One is electron donating group, methyl. One is electron withdrawing group, nitro. Para-nitrobenzoic acid and para-methyl benzoic acid. So, if we talk about para-methyl benzoic acid, this is in negative charge. Okay, anionic form, negatively charged. If electron donating group comes, this needs to be stabilized. How it will get stabilized? So by becoming neutral. Okay, by becoming neutral. But here is there is negative charge. Electron donating group donate electron, so it is full of pay. Okay, it has its dinner full. Okay, various dishes, and you are giving it much. So what happens? What happens? It will vomit and becomes destabilized. It will becomes destabilized. And electron withdrawing group, what happen? Stabilize this anion, withdraws electron from this COO minus. So here it is written, electron withdrawing group increase acidity, electron withdrawing group withdraw electron density from the carboxylic group, and equilibrium shifted to right. Okay, so equilibrium shifted to right, and that's why increases the acidity of carboxylic acid, while electron donating group decreases the acidity. How? It adds the electron density to carboxylic acid, and equilibrium shifted to left. Thus the more the compound remains stable in this form, it will become more acidic. So here is like electron withdrawing group increase acidity and electron donating group decrease acidity. Okay, you can see here RCONH2. Okay, another example like RCONH2, it is less acidic, and RCOCl, it is more acidic, because this is electron withdrawing group, this is electron donating group. Okay, so this is about acidity and basicity of carboxylic acid and basicity of aromatic amines. Okay, so remember this thing. So thank you so much. Today we will stop here. In next lecture we will learn about something more about chemistry, name reaction and other things, and then we will learn about medicinal chemistry. Okay. So if you have any doubt in this session, you can just ask by unmuting yourself. Okay. Just remember this thing. This is important thing. If you have any doubt, you can ask. Meanwhile, MCQ discussion. Yeah, we have carried out MCQ discussion that which kind of MCQ can be asked in from each and every section. Okay, but if you want, we can do it one more time. Just give me 2 minutes. We have discussed it that which kind of MCQs will be asked. Okay, so I am sharing my slide. Meanwhile, if you have any doubt, you can ask. Okay, I will come up with MCQ discussion. So, can you see my slides? So, for this organic chemistry, you can refer Morrison Boyd or Jerry March book. IL Finar is also. So, first question is like, which is most reactive in electrophilic substitution reaction? Give me answer. Which one will be more reactive? Just write in chat box or you can unmute yourself and give answer. You have four compounds. Most reactive compounds you have to identify. Which one is most reactive? Anyone? You have time, 2 minutes time. Take your time and give answer. Okay, in chat box or unmute yourself and give answer. If you will unmute yourself, we might have healthy discussion. Okay, so which will be most reactive? Anyone?
Option C, sir.
Option C. Okay. So
Option B, sir. I
option
think
B.
yes, sir.
Yeah. So option B is correct. Option B is correct. Why? Because as we have discussed, electron donating groups are activating groups. Activating groups means the activating ring towards electrophilic substitution reaction, while electron withdrawing group deactivates ring towards electrophilic substitution reaction. So we have to identify which one is electron donating and which one is electron withdrawing group. So in option A, is this electron donating or electron withdrawing? Option A, CH2 CH3 is electron donating or withdrawing? Anyone?
Electron donating group, sir.
This will become electron donating. Okay. Here OCH3 option B, it is also electron donating group.
Donate.
And another option C and D are electron withdrawing groups. Okay, or option C and D are electron withdrawing groups. Now the answer should be either option A or option B, because electron withdrawing groups are deactivating groups. So option C and D itself gets omitted. So the answer should be option A and B. So what will be the answer? The relative strength. Now OCH3 is more electron donating group as compared to CH2 CH3, and that's why option B is the correct answer, that this compound is most reactive in electrophilic aromatic substitution reaction. Are you getting? Okay. So this is about these kind of questions will be asked. Another question. We have not covered this, but this is simple question, very simple. What will be the product in this reaction? We have not covered, but we will discuss in this MCQ only. Just think 2 to 5 minutes and then give answer.
Sir, answer C, sir.
Answer C incorrect. Option C is not correct. Yeah, Isha. Yes. Option A is the correct answer. So which reaction is this? Can anyone tell? Option A is the correct answer. But which reaction is this?
Bromination.
No, not bromination. Anyone can give correct answer. Which reaction is this? It is name reaction. Not exactly name reaction, but
Sir, elimination reaction, sir. It is an
elimination.
oxygen.
No, no, it is addition reaction. Double bond HBr, HBr. Here HBr is added between these double bond. Option A is correct answer. Here on one carbon hydrogen is added and on another carbon Br is added. They will not give you structure like He and Br is added. So this is addition reaction. This is anti-Markovnikov addition reaction. Anti-Markovnikov addition reaction. Okay. Why anti-Markovnikov addition reaction? Here peroxide is shown, ROOR. So if HBr and ROOR is nothing but it is peroxide. Okay. So peroxide is present and that's why you will get product having bromine attached with carbon having more number of hydrogen according to anti-Markovnikov rule. And in Markovnikov rule, hydrogen will go with the carbon having more number of hydrogen. Okay. Can anyone tell another name of anti-Markovnikov addition? It is another name is peroxide effect and another name is Kharas effect. Very good, Yoga Chaitanya. Okay, Kharas effect, peroxide effect, and anti-Markovnikov addition. All these things are same. Okay, so you will get this product anti-Markovnikov product. Why? Because peroxide is present. You know it is very simple reaction. But when it is asked like this, the question like this will get you confused. Okay? So you have to use your brain. Next question. What is the product of the following synthesis? Now, tell me. You might have 5 minutes for this. Is it visible to you? Or you can zoom in your screen. Okay. Think you have 5 minutes time. Come up with correct answer. So option B. Okay. B. Okay. So we will go with the reaction. So first is nitration. What will be the product in first reaction? So nitro group will come. Here two possibility ortho to OCH3 as well as ortho to CH3. So as OCH3 is stronger group, so nitro group will attach with ortho to OCH3. In next step FeHCl, that is reducing agent. Reducing agent will reduce nitro group to NH2 group. NH2. Okay, nitro will reduce to amines. So in second step, amine will be there. In third step, NaOH and HONO. So NaOH will neutralize the reaction. NaOH will neutralize the reaction. Here acidic medium will be neutralized by NaOH. So Na3 plus. Here it will be in Na3 plus form. So it will converted into NH2, and in next step HONO. HONO means HNO2, that is NaNO2 plus HCl, that will form diazonium salt. So here NH2 will be converted into aryl diazonium salt, N double bond NCl, N double bond NCl, and in final steps UCl, that is nothing but Sand-Meyer reaction. Sand-Meyer reaction is there. So here Cl will come at this position. So the correct answer will be option C. Okay. The correct answer will be option C. Why not option B? They give this option B to get you confused. Just look at the starting material. OCH3 and CH3 are para to each other. In option B, OCH3 and CH3 are meta to each other. Okay. You can see. Can you see? Okay, are you getting what am I what I want to tell you? Okay, option B and C. You will take option B. Two of you gave answer just like option B. Your thinking is correct, but the correct answer is option C. Why? OCH3 and CH3 are meta to each other in option B, while OCH3 and CH3 are para to each other. The position will not change. Okay, position of OCH3 and CH3 will not change. It should be para only. Okay, so the answer will be option C. Okay, Afiza asked us, sir, what is the difference between anti-aromatic and non-aromatic compound?
Sir, I had a doubt, sir.
Yeah.
Here it is oxygen has an CH3, so maybe here when it is joined at NO2, maybe it get a steric effect, sir.
No,
Last position.
no steric effect because oxygen is a strong activating group and CH3 can be one side. Okay, CH3 can be one side. So if CH3 is this side, so it can NO2 group can attach on this side. Are
Okay.
you getting? Yeah.
Okay, sir.
If it is like NCH3CH3 dimethylamine,
Okay.
then it might be problematic. But for only single CH3, the group can come here. Okay. Yeah.
Okay, sir.
Yeah. So the difference between non-aromatic and anti-aromatic compound. So if compound have conjugation and 4n pi electron, cyclic planar conjugation and 4n pi electron, then it will become anti-aromatic. While if compound do not have conjugation, in non-aromatic compound does not contain conjugation. Conjugation means alternate single bond, double bond, or lone pair of electrons like that. Okay, so conjugation is not there, then it will become non-aromatic, and if conjugation is there, then it will become anti-aromatic or aromatic. So this is about the same thing. Okay. Uh, Another question, yes. So name reaction. Here, one name reaction is there. Can you identify this reaction? It is very common reaction. And this question is asked 3 to 4 times in GPAT exam. So correct option C is the correct answer. It is Riemann-Tiemann reaction. Chloroform and NaOH reacts together to give aldehyde. Okay, salicylaldehyde is formed in this reaction, and this is the first reaction for the synthesis of aspirin. Then salicylaldehyde converted to salicylic acid, and salicylic acid converted to acetyl salicylic acid, that is aspirin. Okay, so this is the reaction, Riemann-Tiemann reaction. Another, yeah. Now, which is a defective resonance contributor of naphthalene? Tell me. Option A, B, C, D. Which is defective resonance contributor of naphthalene? Yeah, correct. Option C is the correct. Okay. So here we have started with methane. Carbon have 4 valency. So if we look at this carbon, okay, in option C, if we look at this carbon, it has 1, 2, 3, 4, 5 valency. 1, 2, 3, 4, 5 valency. Moreover, this option C have 3 and 3 6 pi bond, means 12 pi electrons. As naphthalene is aromatic, it is not anti-aromatic. So the correct answer is option C. You can easily identify this. Okay. So option C is the correct answer. Okay. Then another question is like, what is the correct order of reactivity of pyrrole, furan, and thiophene towards electrophiles? This is somewhat tricky question. Can anyone answer? Pyrrole, furan, and thiophene.
Sir, both questions have the answer C, sir.
Yeah, both option have answer C. Yeah, good. Correct. Okay. So pyrrole is the most reactive because uh, it is nitrogen containing ring and nitrogen donates electron in ring. If it is ring, then nitrogen donates more electron to ring. So pyrrole is the most reactive for electrophile, then furan, and the least reactive is thiophene. Okay, so option C will be the correct answer. And in glucose has how many optical isomer? So how you count this? 15 is correct answer, but how you count it?
Sir, formula 2 to the power of n, sir.
2 to the power of n. So in glucose there
N,
are
sir.
four chiral carbon, four stereo
Yes, sir.
centers are there, and that's why 2 raised to 4 is 16. That's how glucose have 16 stereoisomers. Okay. So in next, which of the following Fisher projection is different from the other three? Which is different from other three? Can you tell? Which is different from other three?
Answer
Option
4, sir.
C is incorrect. Answer 4 is the correct.
Oh,
Okay. Answer 4 is correct answer. So how to check? So if we take pH, suppose we take pH, so pH HCl3OH. In this pH HCl3OH. In this pH HCl3OH. In this pH HO. No H. Okay. So this is different from other three. So the correct answer is 4. Okay. Thus yeah, this is like tricky. There is no use of like any special formula or your chemistry knowledge. It is simple. Okay. Another is which of the following group has the highest priority according to Kahn-Ingold Prelog sequence rules? Do you know about CIP system, Kahn-Ingold Prelog sequence rule? Option C, no. Option D, correct. So the answer is option D. Okay, so according to Kahn-Ingold Prelog system, compound having a high atomic number will get first priority. High atomic number compound. Okay, high atomic number atom will get first priority, but here first atom is same in all. Okay, if we talk about second atom, in all hydrogen is there. If we talk about third atom, hydrogen, hydrogen, hydrogen. Here, oxygen. CHO is like C double bond OH. C double bond OH. So, according to fourth rule of CIP system, okay, according to fourth rule, if double bond is there, then you can duplicate the atom. So, according to CIP, this is like CO2H. Okay, it is like CO2H and that's why the correct answer is option D. And then second priority, which compound will get second priority? First priority is CHO. Okay, correct. Then second priority, no C, it is B. Okay, here after CH2, Cl, high atomic number. So option B will get second priority. Option C will get third priority. Option C will get third priority, and option A will get fourth priority. Option A will get fourth priority. Okay. Next, which of the following molecule does not possess enantiomer? Okay, tell. Option B, correct. Okay. So enantiomer means the basic requirement for any compound to be enantiomer, it should contain chiral carbon. Okay, chiral carbon. Then it should be mirror image and non-superimposable. Okay. Chiral carbon means carbon having four different atoms in first compound. This carbon number one, two, three, four. Fourth carbon have four different atoms like one is propyl group, one is methyl group, one is hydrogen, one is bromine. But in option B, the second carbon, sorry, third carbon, it is Br2. So Br, no chirality, no chirality. So no enantiomerism is possible in option B. While in other option, like here also option C, one methyl, one ethyl, one hydrogen, one bromine. Okay. And in option D, these one, two, and third carbon, one methyl, one this bromine containing group, one hydrogen, and one bromine is there. That's why option B is the correct answer. It does not have any enantiomerism possible because it does not contain aryl carbon. That's why. Okay. Would the following compound have an enantiomer? Enantiomerism is possible in this compound or not? Why? Why no? Unmute yourself and tell. Yeah, very good. It is heteroisomerism. Okay. Biphenyl system. In heteroisomerism means restricted rotation to single bond. Okay, heteroisomerism is possible in biphenyl except biphenyl. In which compound heteroisomerism is possible? Can anyone say? Except biphenyl, in which compound heteroisomerism is possible? Restricted rotation around single bond. Heteroisomerism. Heteroisomerism is possible in biphenyl as well as in allenes. Allenes and spiro compounds. Okay, remember these things. Allenes, and spiro compounds. Allenes, spiro compounds, and biphenyl show heteroisomerism, that is restricted rotation. Okay. Then the term heteroisomerase is used for isomers. So I have already told that can be interconverted by rotation about single bond. Okay, so the option A will be the correct answer. Option A. Then yeah, here medicinal chemistry MCQs are there, and I also give an answer. The following general structure is representative of sulfonamides. Which of the following statement is true for active sulfonamide? Okay. So aromatic ring is essential in sulfonamide. If aromatic ring is not present, then the compound will become inactive. So the option A will be the correct, sorry, option C will be the correct answer, that the aromatic ring is essential for sulfonamide. Another option, what reaction is catalyzed by a beta lactamase enzyme? Tell the answer. Beta lactamase enzyme. Which reaction will be catalyzed by beta lactamase enzyme? Yes. So the answer is option C. The hydrolysis of four-membered ring present in penicillin. Beta lactamase hydrolyze the four-membered ring, and that's why it inactivate the penicillins. Beta lactamase enzyme in bacteria inactivates penicillin, and that's why we need beta lactamase inhibitors. We need beta lactamase inhibitor. So as we have started this penicillin, so penicillin have three disadvantages. Okay, basic penicillin have three disadvantages. One is like penicillin are acid sensitive. Penicillins are acid sensitive. Acid sensitive, so it cannot give orally. Acid sensitive, in acidic condition, compound gets degraded. So you cannot give it orally because in stomach it gets hydrolyzed and compound becomes inactive. So you cannot give orally because it is acid sensitive. Another disadvantage is it it becomes inactive in presence of beta lactamase enzyme. Second disadvantage, it inactivates it becomes inactivate in presence of beta lactamase enzyme. First is acid sensitive, second is beta lactamase enzyme, and third is it is only active against gram positive bacteria. Okay, third disadvantage is like it is only active against gram positive bacteria. Gram positive bacteria. Okay, so if you want, you can write it down. Three disadvantages are there. First is acid sensitive, beta lactamase sensitive, and third one is gram positive effective. Okay, so to overcome these disadvantages, what can be done? So first disadvantage is like acid sensitive. So to give oral penicillin, you need to introduce electron withdrawing group in side chain. Okay, so if electron withdrawing group is present in amino acyl side chain, just think about structure of penicillin. If electron withdrawing group is present in amino acyl side chain, then it becomes acid resistance. Okay, first it was acid sensitive, means it gets degraded in acidic condition. If electron withdrawing group is present in side chain, then it becomes acid resistance. So you can now give oral penicillin. Okay. If compound have electron withdrawing group in side chain, then it becomes electron resistance. Okay. Sorry, acid resistance. Another disadvantage is beta lactamase enzyme. Okay, beta lactamase enzyme open four-membered ring. So how to overcome it? If steric group is present in amino acyl side chain, steric group, okay, steric hindrance, steric group is present in amino acyl side chain, then beta lactamase resistant penicillin can be synthesized. Acid resistance side chain electron withdrawing group, beta lactamase resistant side chain steric group. Okay, side chain steric group, beta lactamase resistance, side chain electron withdrawing group, acid resistance. And third example, disadvantage is effective only against gram positive bacteria. It is effective against gram positive bacteria. Okay. So if you also want effect against gram negative bacteria, then what can you do? If you have polar group like NH2, OH, COOH next to carbonyl carbon of amino acyl side chain. Okay. If you have polar group next to carbonyl carbon of amino acyl side chain, polar group like NH2, COOH, OH, then compound can penetrate to porin channels of gram negative bacteria. Compound can also penetrate through porin channels of gram negative bacteria, and thus compound become gram negative as well as gram positive effective. Okay, compound can become active against gram negative as well as gram positive bacteria. So three disadvantages of penicillin. First one is acid sensitive amino acyl side chain electron withdrawing group. Second one is beta lactamase sensitive steric group in amino acyl side chain. Third one is effective only against gram positive bacteria. Polar group next to carbonyl carbon in amino acyl side chain. So these are the three disadvantages, and how you can overcome these disadvantages. So question can be asked from these also. Another one is the starting material required for the synthesis of chlorambucil are. So just you need to remember the structure of chlorambucil. If you remember the structure of chlorambucil, so the answer will be like para-amino phenyl butyric acid, okay, and ethylene dioxide, ethylene oxide, okay. So here options are para-amino phenyl benzoic acid cannot be possible because benzoic acid is not here, okay. It is butyric acid is there, and that's why answer is para-aminophenyl butyric acid and ethylene oxide. Okay. Then this is my favorite question, which was asked in GPAT. Can you give answer for this? AUG, that codon B. So I will tell B is incorrect. Okay. B is incorrect. Just take 2 minutes. Think, read question, think, and give answer. Yes, on template stand. So on template stand, it will decode AUG start codon. Template stand, it will decode like A again, T against A, U against A, and G against C. So the correct answer will be option A. So this kind of tricky question they will ask. Okay, template strand on DNA will always begin with TAC. Okay, so the correct answer will be option A, TAC. So read question twice before giving answer. Don't to make such hurry. Okay, so the correct answer is TAC. Then physical chemistry. Which molecule has the largest dipole moment? Largest dipole moment, which have largest electronegativity difference. CCl4 zero dipole, H2S sulfur is low electronegativity than chlorine, and that's why option A will be the correct answer. Okay. In next, which of the following bond is the most polar? So most electronegativity difference like OH here. OH is have most electronegativity difference, and that's why option B is the correct answer. Then these question, they ask sometimes this kind of question, calculation of specific rotation. Okay, what is the specific rotation of following compound? They give observed rotation, concentration, and the length of sample cell. Okay, but what is required to remember this equation? Specific rotation is equal to observed rotation divided by concentration multiplied by length of sample cell. Okay, so 4.42 divided by 0.1 multiplied by 10. So the answer will be 4.42. Okay, so the option A will be the answer. So these are some questions which we have discussed. Okay, and if you have more doubt or you come up with more question like this, we can discuss in next session. Okay, so I hope you got everything or you understand something from this lecture and might be beneficial for you. And I want to see you in top 100 in GPAT examination. Just uh, Swarali, then just a second. Second, Yoga Chaitanya, Afiza, okay, Isha, Soumya, Swarali, Yoga Chaitanya. All the best. And if you have any doubt, you can come up. I will share this presentation with Bandu sir, and he will share with you guys. Okay, or by Monday. So by Monday, I will share it in our group. That which group? Pharmacy Success Hub? No, which group? GPAT Booster. Yeah, GPAT Booster course. I will share it in that group. PPT. I will share in GPAT Booster group on Monday or Tuesday. Okay. Meanwhile, just read or revise what we have discussed today. Okay. So thank you very much. If you have any doubt, still you can ask. Okay. You can reach out to me anytime. I am in that group also, GPAT Booster. Okay. So you can just find my number and you can message me. Thank you so much. If you do not have any doubt, we can leave. Okay. All the best.